In the holidays, Kerem went to mathematics camp with Eva, Lin, and Ole from his school. All participants stayed in a 4-story house. There were 25 children on floors higher than Eva, and 10 children on floors higher than Lin. There were 5 children below Ole and 2 children below Kerem. The number of children accommodated above Kerem is a multiple of the number accommodated beneath him. How many children were at the camp in total? This is a logic reasoning and plus math question. We must deduce the necessary information from what has been given. This task is to figure out the relative positions of the individuals and ideally their exact floors. So, let's start with the first condition. So we separate 2 parts. One is the given in the text, or we can say it's given conditions. And from the conditions, what we are reasoning and which kind of concurrence we can draw. So let's look at the first one. So there are 25 children on floors higher than Eva, and there are 10 children on floors higher than Lin. What we can deduce? So clearly, Lin must be higher on a higher floor than Eva, and also Lin cannot be on the 4th floor because there are still children above him. So the Lin either 2nd or 3rd floor, Eva or 1st or 2nd floor. So now let's look at the next condition. 5 children below Ole and 2 children below Kerem. So which also means Ole is above Kerem, and Ole cannot be at the 4th floor because only 5 children are below him, and otherwise it will contradict with the first condition, 25 children above Eva and 10 children above Lin. So Ole cannot be at the 4th floor. So Kerem must be at the 2nd floor since there are children also below him. So that means Ole is higher than Kerem, is at the 3rd floor, and the Kerem is at the 2nd floor. And we also look at the last condition. Above Kerem is a multiple of below. So which means below Kerem is 2 children. So that's the number above Kerem is a multiple of 2. So once we fix the positions of Kerem and Ole, we can look into the possible floors for Eva and Lin. So we fix the position. Ole is in 3rd floor, and Kerem is at the Ole is at the 3rd floor, Kerem is at the 2nd floor. But we cannot only determine the floor, but we also can determine how many children are on each of these floors. For example, below Kerem, there are 2 children, so we note there are 2 children on the 1st floor. Since there are 5 children below Ole and 2 are already under Kerem, there must be 3 children on the 2nd floor, marking 5 children below Ole in total. So, now, let's assume Eva is on the 1st floor and Lin is on the 2nd floor. According to the conditions, there are 25 children above Eva and 10 above Lin, which means there would have to be 15 children on the 2nd floor. However, we already determined there were only 3 children on that floor, so this arrangement cannot be correct. Now, we suppose that Eva is still at the 1st floor, but Lin is on the 3rd floor. Then with 25 children above Eva and 10 above Lin, there must be 12 children on the 3rd floor. Since 25 minus 10 is 15 and 3 already under Lin, therefore only 12 at the 3rd floor. Now let's look at the third condition. The number of children above Kerem must be a multiple of the number below him. So Kerem has 22 children above him and 2 below, and 22 is a multiple of 2, so this arrangement is valid. In total, will be 25 above Eva and 2 below Kerem, and we can get 27 children. So the answer is A. But when solving this kind of problem, during examination, once you find a consistent solution, you can stop to save time because only one solution is correct. But for explanation, I would like to look at the third possibility anyway. So now we suppose that Eva is on the second floor and Lynn is on the third floor. Again, 12 children above Eva and 10 above Lynn would require that 15 children on Lynn's floor. But in this setup, there are 25 children above Karen and still 2 below Karen, and 25 is not a multiple of 2. So this option is also invalid.